As we know that in the previous video I discussed with you all image formation, mirror formula and magnification. Okay, this is our new topic, refraction of light. Previous time I discussed with you all reflection of light, but in this video we will discuss with you all refraction of light. Clear? Simply first of all we will try to understand this refraction of light concept by diagram only. Clear? One thing, listen, I am explaining and later I will tell cause of reflection of light. Okay, one thing, listen, I am telling to you all, when light goes from air to glass, simply we will select here two things. Number one is air, second is glass. Why we are taking here air and glass? Before starting a refraction of light, simply I have to explain both things, meaning of both things. One is air, second is glass. What is the meaning of them? Then listen carefully. Listen student, I am explaining here optical medium. What is the meaning of optical medium? Optical means what? Where we will work by light only. Medium means any medium, can be air, glass, anything else. Clear? So first of all we will discuss here optical medium means for refraction of light we need two medium. One can be air, second can be denser medium. One can be air, second can be denser medium. Clear? Then first of all we will try to understand what is the meaning of medium. What is the meaning of medium? Okay, then listen carefully student. Simply we can see here air, second is glass. So air, in air we can say different molecules can be there. Then separation between the molecules too much means molecules will very far away to each other. But in the case of glass, so we can say molecule will be very closely packed because it is a solid. Or this is what? Gas. Clear? When molecule will very far away to each other, so this medium we can say that can be air, or this medium we can say that is rare medium. Rare medium. When molecule will very close, so on that time we can say this will be denser medium. Which medium? Denser medium. Means it depends on the density only. Density only. Means that medium which have less density than that of other. Then that medium which has less density, so we can say that medium will comes in rare concept, a rare part, and other medium will be in the denser. So we can say it will be denser medium. Say yes or no. Simply I can take any another medium also. In between water and glass, tell me student which will be rare and which will be denser. So we can say water is rare medium and glass is denser medium. So simply we have to see the arrangement of molecules. In that medium where molecule very far away to each other, they simply will be less distance apart. So we can say that medium will comes in rare. We can say that is rare medium. And second, another medium will be denser medium. Say yes or no. So we can take here two medium. Any two medium we can take. Air, glass we can take. Simply air, glass. या फिर we can say air, water we can take. Air, glass we can take. या फिर water, glass we can take. So you have to see the molecular arrangement. In air, molecular will be far apart. So we can say this will be rare medium, this will be denser medium. In both cases, this will be rare, this will be denser medium. Or in water and glass, so we can say water will be rare medium and glass will be denser medium. Say yes or no. So this is the basic explanation about the denser and rare medium. Means it depends on the density of the medium, density of the system. If more density, so we can say it will come in the denser system, and if it has less density, so you can say it will come in the rare system, in rare part. Clear? So I explained here two things. One is the rare medium, second is the denser medium. Second thing, for refraction we need two medium. One should be rare or second should be the denser medium, and one line, that one which will separate both medium. We can say upside we can say air, downside we can say water. So we will draw here one line, that line which will separate both medium. So we can say this is the permeable line. Clear na? So we can say the simple one line, optical line, which will separate both medium, rare and denser medium. Air will be the rare medium and water will be the denser medium. Say yes or no. Say yes or no. So this is the basic detail for getting refraction of light. You should understand this one. It's a compulsory for you all. Clear? First of all, before getting a refraction part, so we have to understand a rare and a denser medium. I explained here everything clearly. Clear? Now we will try to understand this concept by diagram only. Listen one thing. See student, later I will tell cause of refraction. Why refraction we are getting. So simply later I will explain. First try to understand by diagram only. Listen one thing. So we can say upside will be air. Air means we can say this medium is the rare medium. Or second thing we can say, what is this? This is the denser medium. Denser medium we can say this is what? Water. Yeah, you can take this can be glass. You can take anything. Clear? So first of all, this is that line which will separate both medium. We can say optical line. Clear? The one thing listen, draw normal on this line. Draw normal on this line. As same like it. Means normal is the perpendicular to the surface. Perpendicular to the surface. You can see it will make 90-degree angle here. Clear? The one thing in this case we will take ray. I told you in the case of reflection of light, we will do both reflection and refraction by the help of this one only, ray part, by ray optics only. Clear? Listen one thing, ray will come. So we can say this point is O. So ray will come and strike to the point, we can say where? We can say at this point, O point. Clear? Means normal, that point, this normal will cut the optical lines, optical medium separated line. Clear? You can say direction of this line as same like it. So we can say this is rare medium, this is your denser medium. So here we can say light can travel freely without any force because molecule will be very far from each other. But in this case, water or glass, molecule are very closely packed. When light will travel, try to enter in this medium, so on that time this light will feel the very highly force. Clear? So we can say light should travel as same like it. Means we can say the path of light should be as same like it. But in real manner, it will not like that. Clear? So you can see from O point, light will bend towards normal. So we can say this is your, we can say what? Incident light. Incident ray we can say. This is your reflected light. Refracted bachcho. Refracted. We are studying a refraction, so this is refracted ray. Clear? One thing, you can say this is what? Normal. This is your rare medium. This is your denser medium. One thing, listen. Now we will try to understand angle concept. So we can say this is your normal or this is your incident ray. Between normal and incident ray, this will be what? Angle of incidence. Angle of incidence. Angle, we can say this angle of incidence I. It will be in between incident ray and normal. Some students can take here also. No, it will be wrong. But simple one thing, see here, angle between incident ray and normal, this will be angle of incidence. Clear? And this one we can say this is angle of refraction. This angle of refraction. Okay or not? Okay. Which things you are observing here? You can see this angle is larger or this angle is smaller. So you can see angle I greater than angle R only when light will travel from rare medium to denser medium. If someone will give to you this condition, you have only one condition, that is angle I greater than angle R. So you will tell there simply light is traveling from rare to denser medium. Clear? We can say air to glass, air to water, water to glass, anything you can take. Okay student? So this is your first one. When light will travel from rare to denser medium. Say yes or no? Say yes or no? So simply direction also you will mention. Without direction it can be wrong. So you have to show here direction also. Clear student? Any doubt now? So simply come on the next point. So we can say when light will travel from denser to rare medium. Means we can say light will travel from glass to water. Glass to water. So we can say yeah, glass to air. No problem. So simply same thing you will do. You will draw here optical medium separated line. This one, take point O here and draw normal on it. as same like it. This is a normal. Clear student? This is a normal only. Clear? So we can say upside you can take that is glass. Glass mean you can say this is denser medium. Okay? Or downside you can take which medium? Rare medium. Rare medium it can be air. Try to understand bache concept. Try to understand. This is your normal. Normal. Same thing you will take incident ray. Which ray? You can take this one incident ray. So incident ray will make angle with normal. This angle we can say that is angle of incidence. So देखो you can see light is traveling from denser medium to rare medium. Denser medium to rare medium. Light should travel as same like it. Say yes or no. But you can see when light will travel from denser to rare. So in denser medium it will feel there some force of the molecule. Due to this it will not move freely. When it will come into the air. So simply in free medium. So it will spread. Spread means a little bit move away from the normal as same like it. Say yes or no. So this is a simple explanation of refraction of light from denser to rare medium. So you can see this angle will be means angle between refracted ray and we can say that is normal. So this angle is called what? Angle of refraction. Angle of refraction. Okay or not okay? Or this is your refracted ray. Don't forget, don't merge reflection and refraction. So this is a refracted ray. This is your refracted ray. And you can see here angle I and this angle R. Which angle can be more here? So we can say angle I is less than that of angle R. So angle I less than angle R. Clear? If angle I less than angle R, so on that time you can say light. Light means ray. Travels from denser to rare medium. Denser to rare medium. Say yes or no, student. Say yes or no. Rare medium. But simply you can write here rare medium as same like it, and main spelling of it you can say rare. Okay or not okay? No problem. This is your choice. You can write rare also. It's not a big issue. Okay, student. Next thing. Next topic is there. Cause of refraction of light. Cause of refraction of light. Means which reason will comes in the back side of the refraction. Why refraction is coming? What is the role of which cause will play here role in the case of refraction? So these things I will discuss with you all. Listen carefully, student. This question can come in the exam. This can be very important. So we can say, listen, I am writing a simple definition. The refraction of light take place. The refraction of light takes place. Why takes place? Because speed of light changes. Speed of light changes when light goes, ray you can say, ray goes from one medium to another. Simply we can say a refraction takes place only when light will travel from one medium to second medium, so its speed will change. Simply speed of light will work behind the refraction concept. So listen carefully. We come across many media like air, glass, water, etc. through which light is transmitted. A medium through which light can pass or transmitted is called a transparent medium. We can say transparent medium is what? Through which light can pass easily. You can take glass, you can take water, so all those things which through which light can pass easily. So you can say simply that medium will work for the refraction. So we can say refraction can take place there. Clear? Next, every transparent medium has a property known as optical density. The optical density of a transparent medium is closely related to the speed of light in the medium. So see, we can say speed totally connected with density. We can say you have a different density medium. You can say simply air, and second is water, third is what? Glass. So this is what? Gas. This is what? Liquid. Or this is what? We can say solid. So you know density is equal to what? Mass by volume. Say yes or no. So simply we will talk about volume. So in the case of gases, gas will spread in whole space easily. So we can say it has more volume. So if it has more volume, so we can say its density will be less. Density will be less. So we can say in this case, density is less. Clear? So in water case, you can say volume little bit less than that of gas. So in this case, density will be more. But in the case of solid, you can say in the solid, volume will be very less. So means solid will cover very small space. So you can say its volume very less. So density will be more. So glass has their more density. Density I'm telling. Density of glass more. Density of water more. Density of we can say gas. So we can say glass density will be highest, intermediate, and we can say very less density of glass. Clear? So this speed totally depend on density. This speed will totally depend on density. If density is less means what? The molecule will be very far away to each other. Clear? So when light will travel through this any means we can say less denser medium, so these molecule will not apply force on this light. The light can travel easily through the simply rare medium. Yeah, you can say they are less denser medium. So we can say light speed will be more. Clear? Dekho, you can talk about vacuum. We can talk about vacuum. So simply in this case, in the case of vacuum, light will travel with highest speed velocity, that is 3 into 10 to the 8 meter per second, because there is not a means a pressure, no medium is there. Clear? But one thing, second thing I'm telling, in air speed equivalent near about to 3 into 10 to the 8 meter per second. So on that time we can say some medium will come there. So when the medium will come, on that time speed of light will decrease a little bit, because molecule will come there now. So this molecule will apply force on the light, and this when this molecule will apply force, the speed will decrease of the light. Clear? And when we will talk about water, so in the case of water, you can see water will be much more closely than that of air. So when light will try to pass through this water medium, transparent medium, so on that time this molecule will apply force on this light. So when molecule will apply force on the light, so simply the speed of light will decrease by applying force by the molecule. Or in the case of glass, you can see molecule will be very closely packed, because this is solid, maximum density, more density. Clear? So on that time when light will travel through it, so these molecule will apply much more force than that of water or than that of air. So in this case, the speed of light will be very, very less. So in the case of refraction only, speed will take part for getting refraction only. Clear? So I told you now, simple basic case. Here, this is rare medium, this is your denser medium. Light will travel from rare to denser medium. On that time you can say here less force. So light will travel direct, straight. But one thing, listen, when it will change its medium, transparent medium means we can say water or glass, so you can see its molecule very closely packed. So on that time this molecule will apply force on the light, the light will bend because its speed will decrease. Clear? And in this case you can see here, this is your denser medium. Light will travel straight. When it will change its medium, on that time light will feel their less force, so it will become free. So its speed will increase. By increasing speed, the gap between normal and the this refracted light will increase. Say yes or no? So this cause will comes in the back of refraction of light. We can say the refraction of light takes place because speed of light changes when light pass from one medium to another medium. Say yes or no? So simply one basic thing will behind refraction. Listen carefully, student. Listen carefully. The speed of light is that medium is high, because this medium is less denser. Clear? So such a medium known as optical rare medium. Thus optical rare medium is that medium through which light transfer fast. Means in rare medium the speed of light will be more and more, like that air, vacuum, or any another medium you can include here, your choice, rare medium. Clear? And another medium we can say, on the other hand, the optical denser of a transparent medium is high, denser, high. Then speed of light in that medium is low. Such a medium is known as optical denser medium. Optical means lighter, denser means where light will pass. That medium is called denser medium. Thus optical denser medium is that medium through which light travels slow. Say completely about refraction. Means we can say when light will travel from rare to denser medium, it will bend towards normal and will simply denser to rare, it will away from the normal. Clear? We will discuss in the case of rare medium, simply angle I greater than angle R, so we can say light travel from rare to denser medium. If angle I less than angle R, so we can say light traveling from denser to rare medium. Say yes or no? Say yes or no? So simply I explained here denser to rare and rare to denser, or speed will means simply work behind the refraction only. So simply in this here, next topic is there, laws of reflection. We can say laws of refraction. Say yes or no? So we'll discuss here about laws of refraction. Number one is there, listen student, the incident ray, the refracted ray. Number one, the incident ray and the refracted ray. The incident ray and the refracted ray and the normal to the surface separating to media, all lie in the same plane. All lie in the same plane. Simple thing you can understand. Dekho, listen one thing. This is your optical separated media line. Normal, incident ray, refracted ray. Because this rare medium, denser medium, light should travel as same like it, but it will bend toward normal. Angle R, this angle I. So you can see normal, surface, incident ray and refracted ray all are present at one point only. Yeah, connected at one point only. Yeah, we can say lies in the same plane only. This one plane na, so we can say lies in the same plane. Deeply explanation you will get in wave optics in class 12th only. So this time only simply you have to understand, means what is the meaning of it only. You can see incident ray, normal, plane, or we can say this, that is refracted ray. All are lies in the same plane only. Say yes or no, student? Say yes or no. This is the basic understanding of this first law of refraction. Clear? So we can say all things will be normal to the surface. So you can say light will come as same like it, to strike to the normal plane and bend towards normal. So all things will connect at one point only. You can write at same point only. You can write here, and you can say this all things will be in the same plane only. Say yes or no? So this is the basic understanding of first law. Second law, listen carefully. ये examiner in exam can ask direct one. So this law name can be Snell's law also, we can say. Snell's law. So listen one thing, what is its mean? So देखो, this is your incident angle, this is your refracted angle. So we can say here angle I greater than angle R when light will travel from rare to denser medium. Clear? Or we can say angle R greater than angle I. Yeah, you can say angle I less than angle when light will travel from denser to rare medium. Clear? So this Snell's law comes by this only. So one thing, listen, derivation of it in your syllabus, simply result is there. So you can see here, means you can see the ratio of sine of incident angle, the ratio of sine of incident angle, the ratio of sine of incidence angle and to the sine of refracted angle, ratio and sine of refracted angle is equal to what? Is equal to what? Is constant. Is constant. Listen one thing. So you can take here any angle, angle I. According to it, you will get R angle. If you will increase this angle, so according to it will change. If you will decrease according to it, this angle R also will change. So when you will find out ratio in the form of sine, so you will get always same result, constant number. Clear? So this constant is known as refractive index of the media. So this constant is known as refractive index. I will explain about refractive index in next video. This will be too easy, but very, very important. Refractive index of the medium. On that time I will clear everything related to the refractive index. So next video will be very important. Or this video also, but next video will be very, very important. Clear? Of the medium. So constant is equal to refractive index of the medium in which refracted ray travels with respect to the medium in which incident ray travel. The refractive index denoted by n. Refractive index is denoted by n. So we can say this constant is equal to n. So Snell's law becomes what? Sin n is equal to ratio of sine of angle incidence and ratio of sine of angle refraction, refracted. Clear? So we can say this will be n is equal to sin I upon sin R. Sin I upon sin R. So this law is also known as Snell's law, as it was stated by proof Wilbard Snell. So we can say this law given by the Snell only. So we can say n is equal to sine angle of I is equal to sine angle of R. Clear, student? So we can say here Snell's law, sin I upon sin R is equal to constant. This will be get there. Constant is equal to refractive index of the medium. So we can say n is equal to sin I upon sin R. You can learn this one direct. Clear? So you can understand easily this one. And one thing also I am telling here, how will you write the medium here? Listen one thing. You can see light is traveling from first medium to second medium. Anything you can take. It can be rare, it can be denser, it can be denser, it can be rare. So listen one thing. When light will travel from first medium to second medium, we can say first medium to second medium. How will you write this one in the form of refractive index? Listen, light will fall here on normal. So simply if it will denser, it will move away. If it is rare, so we can say this one denser, it will bend towards normal. So you will write refractive index. Listen how. N, so that medium where light will bend or move away, so that medium you will write first. So we can say this is due to second medium, na? N2, or comes from 1. So N2 1 is equal to what? Sin I upon sin R. Say yes or no? Second thing you can see, if we can say this medium is 3, this medium is 4, so light is traveling from third to fourth, so refraction comes due to only this fourth medium. So in this medium light will bend or move away from the normal. Then how will you write refractive index? N. 4 you will write first, then 3 is equal to sine. In first medium it will make angle of incidence I, second medium it will make angle of refraction, that is R. Clear? So it can be opposite also. If this medium is 6 or this medium is 4, then how will you write? This your first means upside medium. Light means you have to see light is coming from where? From this medium. So we can say that medium where light will bend or away, move away from the normal. So you will write that medium first. And 4 at this medium you will write in back side. And 4 6 is equal to, it will make angle I. We can say sin I, or this divided by sin R. Say yes or no? So this is the basic understanding of Snell's law. So in next video I will explain everything related to it. Velocity also, refractive index types also, everything I will discuss in next video. So try to understand, student. If you will get any doubt, any problem, to write in comment section. So simply I will take your problem. Okay student, God bless you all.